So now for experiment 10, we're looking at the silver group. So we're looking for the presence of silver ion, mercury 1 ion, lead 2 ion. So when we add hydrochloric acid to my nitrate solutions, what we're going to get is we're going to get a precipitate. We're going to get silver chloride, nitric acid, mercury 1, nitric acid, and lead 2, nitric acid. Okay, so let's take a look at the question. Mercuric nitrate. Mercuric, that means it's a +2. Nitrate plus sodium chloride. And when you do this, look up your solubility tables. Okay? And what you'll find is mercuric chloride is soluble in water, so you get no reaction. Everything stays in solution. For the second one, we have lead nitrate plus excess ammonium hydroxide. Okay? Now we know the ammonium hydroxide is in equilibrium to form ammonium ion plus hydroxide ion. Okay? And it's this that can react with lead 2. So what would happen is you would form lead 2 hydroxide, which is a solid, plus ammonium nitrate. Okay? And as I form this, more of my ammonium hydroxide will dissociate and produce more hydroxide in solution. So you're going to get a solid when you do that. Okay. What about silver chloride with nitric acid? Well, that's going the other way from making my precipitate. So this is essentially no reaction. Okay? Number 4. What about silver chloride plus ammonium hydroxide? Okay? In this case, this is 6 molar. Alright, so you have excess. Remember again, you also have 2 equilibria with ammonium hydroxide. Ammonium and the hydroxide, which we've done previously for number 2, and ammonia plus water. Okay? Now we know that this is in equilibrium with forming my silver ion and my chloride ion. Almost all of it's going to be as a solid, but I have a KSP of around the order of 1.3 times 10 to the minus 10. Well, we know that my silver ion plus 2 ammonias gives me the complex, the silver ammonia complex, which has a much higher Kf. So this is aqueous, which means that when I add the ammonium hydroxide, what I get is my complex, which is soluble in water. So that's how we dissolve silver chloride. So you can find the Kf, okay, to be large. And what this does is by combining the two, this means that this becomes soluble. Okay? So, that's what happens when I add the ammonium hydroxide. It's not because it's the base so much as it's because of the ammonia. Okay, lead nitrate plus potassium chromate. Okay, and if you look, we get that precipitate, right? Don't we get this really beautiful, that's that yellow solid here? This is what tells you you have lead 2 in solution plus potassium nitrate. Okay, so that's going to be your reaction. You're going to get the formation of a solid. So this is how we test for lead 2. And the last one, mercurous chloride. So that's mercury 1 plus ammonium hydroxide. Okay, and if you go back to page, the previous page, okay, where do we go? Sorry, I want to give you the page number for it. Number 3, 104. Oh my goodness. All right. Discussion. Hang on one second. Let me see if I can find the page number for you. The discussion. Let's go to page 101. What happens is, in our filter paper, when we add in the ammonium hydroxide, we dissolve my silver chloride, and you're going to get your silver ammonia complex. And in here, if you have the mercury 1 chloride or mercurous chloride, this forms a complex. So, again, this is what you're going to get. This is what you're getting from your ammonium hydroxide. We showed you the equilibrium earlier. And you form this complex. You form a mercury. Notice it's an amide chloride. This is a solid. Okay. This is white. Plus, you just get mercury. This is black. And that's what you see on your filter paper. Plus you get your ammonium chloride. Okay, so what you observe is you observe your filter paper turns black. And this is the equation that you have. And that you add ammonium hydroxide to your mercurous chloride.